Hello students, here we have two pulleys and we have two masses. The pulley is massless, and as you can see here, we have M1 is going down with an acceleration and M2 is going down with an acceleration. As you can see here, we have two different masses. M1 is greater than M2, therefore M1 try to go accelerate downwards and M2 will accelerate upwards. And as you can see here, I also wrote down that here we have acceleration 1, acceleration 1, and then acceleration 2. Okay, so acceleration 1, and we also have acceleration 2. Now generally acceleration 1 is equal to acceleration 2, only then you have to find what is this x. Okay, right now we don't know that, but this one can be also found. So first of all, let's write down equation using the Newton's second law. Okay, then using the Newton's second law, we know that sum of the forces is equal to ma. This is general formula, right? Now let's first of all consider the box on the left side. Before writing down equation for the M1, we have to draw a free body diagram. Free body diagram for the M1 is basically we have what? We have the weight, which is M1G. Then we have here a tension, right? This is a tension 1. Okay, then what about here for the M2? We have the weight, which is M2G. Then here we have a tension, call it tension 2. Okay, now then what about those tensions which is upwards on pulley 1 and pulley 2? So let me call this one as a pulley A. Here I will call it pulley B. Okay, you have to first of all keep in mind that when you have the same rope across the pulleys, then those tensions will be the same. So that what does mean this one? This means that this tension and that tension actually is the same. Okay, so let's call this one tension and tension. Okay, so as I said, these two tensions are the same. Why? Because they connected to the same rope. What about the B? Now we know that this is, as you can see here, we have a red rope, so that means this tension, and that tension is also okay. Now let's write down equation for the mass 1. Okay, so what do we have here? We have here two tensions which is connected to pulley A, which pointing upwards, right? They are the same. Why? Because they're connected to the same rope. So that means we can say that upward tension plus tension, and then here downward rope we have this tension, okay, which is T1, and also this is T1. Okay, as you can see, they are opposite but they have the same magnitude, which means we can say that T plus T is equal to T1, right? Now T1 is equal to what? T1 is equal to the M1G, right? So that means we can say that T plus T is equal to mg. Okay, now if we want to include the, since it's not stationary, it's moving downwards, right, with an acceleration, so that means we have the formula where some of the forces equal to ma. That means if you will take the direction of acceleration as a positive, okay, if you take the direction of acceleration as a positive, then what we're going to write down for the M1? For the M1, then we're going to write down that M1G, the pointing downwards, we said that for the A1, direction of the acceleration will be the positive. Then M1G minus 2 tension is equal to M1A. Okay, this is the equation for the first one. Let's just highlight it. What about for the second mass? For the second mass, as you can see here, we have this tension, right? That tension is actually equal to the M2G, right? So that then we can say that if we say that direction of the acceleration will be the positive, then we can say that tension minus M2G is equal to M2A2. Like, you have to keep in mind that, as I said, the acceleration are not equal. So for the first mass we call it M1A1. For the second mass we call it M2A2. Okay. Now here we have the second equation. Okay. Then what do we have to do now? We have to find a tension from here. First of all, the tension is equal M2A2 plus M2G. Then you take this tension and then you substitute in the first equation. So if you substitute in the first equation, what you will get? You will get M1G minus 2 multiplies this tension, which is M2A2 plus M2G, right? Which is equal to M1A1. Okay. Then what? So let's keep it like this one. M1G minus M2G is equal to 2M2A2 plus M1A1. Okay. Now, okay, so then how can we know that in what cases A1 is equal to A2, okay? Or what should be the multiplication constant? So how can we find it? In order to find that one, first of all, let's look at here. Now, what do we have here? We have here this length, okay? Let me just write down. So we have this length, right? For the A pulley, right? So, okay, sorry guys. Let me just, okay, we have this length. Let me write it down here. Okay, which is actually twice less than this length. Okay, that means we have this length for the rope on the left side, and also for the right side is this one. Okay, so that means that for the pulley A we have what? We have if you say this one S, this is S, right? So as you can see here, for the pulley A, if you add these two ropes, S to S, you will get the same as the length of the rope on the right side for the M2. Okay, so let's write down the equation for this one. So how can we write that equation? We know that we have a formula where S is equal, since initially it was not moving, so initial velocity is 0, so therefore we can say that for the right side, for the mass 2, okay, for the mass 2, S is equal A2 T squared over 2, right? Then what about for the mass 1? For the mass 1, the length is twice less, right? So that means you can say that S divided by 2, okay, is equal to A1 T squared divided by 2. Okay, now if you can just divide M2 by M1 like this one, then what you will get? You will get that is equal to 2. This S will cancel, T squared will cancel, and these 2 will cancel. Then you will get 2 is equal A2 divided by A1. Or you can say that it's equal to 2 times A1 is equal to A2. Okay? This is what we get now. So that means if 2a1 is equal to a2, then we'll come back here. Let's write down that one. 2a1 is equal to a2. Okay, so that means we can say that here m1g minus m2g is equal to m2. Let's keep, okay, so if we want to find I don't know, let's keep it a2 here, right? Then is equal to okay, plus m1. Now a1 is equal to a2 divided by 2. Okay, so we just substituted. So here we said a1 is equal a2 divided by 2. Okay, so we just substituted a1 into a1, then we get a2 divided by 2. So then what else? So let's multiply this both sides of the equation by 2. Okay, multiplied by 2 both sides. Okay, if you multiply both sides, then what you will get? You will get 2 m1g minus m2g is equal 4 times m2a2 plus m1a2. Okay, then you can find basically just a2 here. What will be the acceleration of a2, which is equal to 2m1g minus m2g divided by 4m1, okay, 4m2 plus m1. Okay, now once you get the acceleration of a2, suppose you get it like in terms of numbers, like 4 meter per second squared. Okay, then you want to find what is the acceleration of a1. So if you want to find acceleration of a1, we got that a1 is equal to a2 divided by 2, which means 4 divided by 2, you will get 2 meters per second. So as you can see, acceleration 1 is twice less than acceleration 2. Okay, this is how you solve such a problem.